Lesson 6.1 is regarding perpendicular and angle bisectors. First term that we're going to discuss is the notion of something being equidistant, meaning that we have a point that's the same distance or equal distance from two places. The word or the perpendicular bisector is a theorem that we're going to discuss here. We're going to wind up taking, let's go ahead and make a line here. And on the perpendicular bisector, we're going to take these 2 points A and B. And what we're going to find is that any point that is on the perpendicular bisector is going to be equidistant, okay? So that any point here, let's say that we have this point right here, okay? As long as it is the perpendicular bisector, anything here that's going to be done perpendicularly, that when this is if this is the perpendicular bisector, this guy means that this point right here is the midpoint, and we're going to call this point point P, okay? Any point that is on this perpendicular bisector will wind up being equidistant. And what I mean is, let's take this. We're going to call this guy C. This, CB, and AC have to be congruent. Have to be congruent, okay? And the reason that these 2 points have to be congruent is because we can prove that these triangles are actually congruent, right? And then they would be congruent through corresponding parts. Consider this. PC is going to be congruent to itself reflexively. Because of the perpendicular bisector, PB and AP will wind up being congruent, correct? Because if this is the midpoint, it means that through definition of a midpoint, AP and PB are going to be congruent. So we're doing a little proof here, right? And then, of course, we have these 2 right angles, because when we form one right angle, we form 4, considering those one of those theorems that we worked with earlier in the course. So there's nothing new that we've necessarily learned, but we should know that these 2 triangles, triangle APC, is going to be congruent to triangle BPC because of the SAS triangle congruence. All right, side, angle, side, side, angle, side, right? Where the angle is included. And then because of that, AC and BC will wind up being congruent because of corresponding parts, right? Now, this is why this is significant, is that any point, right? So let's create another point. I'm going to call this point right here C prime, okay? This is like a second, just point C. And if I did the same thing, it's still going to be equidistant, right? See both of those endpoints. Okay. Now, conversely, if we say that we have a whole different figure right here, right? We're just going to say, okay, well, let's take this perpendicular intersection right here. And we have no idea what these 2 lengths are between these 2 points, right? Again, we'll call these points A and B, and we're going to call this point P. We don't know that if it's the midpoint or not, but we could maybe prove that it is. And how are we going to do that? Oops, a little crash there. How can we prove this? Well, it depends. If given that these 2 points are going to be congruent, okay? Or excuse me, these 2 segments are going to be congruent. What we can say is that that if AC and BC are congruent, then the angles opposite have to be, through the converse, have to be congruent, which would make these two, makes P is the perpendicular bisector. Now, a lot of stuff happens from that. 2 points, or two concepts really are going to come to light. One is that this angle and this angle, of course, are both right angles, right? As long as we knew that one of these is a right angle, both are going to be right angles, therefore they're congruent. But moreover, it means that this guy and this guy, right, have to be congruent, because if this is the perpendicular bisector at point P, it means that that's the midpoint between A and B. Moreover, we could again prove congruence through that perpendicular bisector. Now look, we actually have a problem here. If we don't have sufficient information. We can't say that we have this side, right? Because look at that, we have an angle, a side, and then a side. That's problematic, right? That doesn't prove congruence versus side, angle, side. So, let's do some examples. All right. You guys are going to like some of these problems, I have a feeling. Right angle right here. This is point A, point B, point C. This is point D. And the only given is that AD is 27. Well, let's find CD. Well, what would CD equal? Given that AB and BC are congruent, that we have these perpendicular lines, moreover, BD is going to be reflexively congruent, we could use side angle side. However, here's the thing, is that just based upon this information, if we have a midpoint demonstrated through two congruent segments that are also perpendicular, this is the perpendicular bisector. Remember, we can use that upside down T to mean perpendicular. The reason I know that, because that's the way it's illustrated. If BD is the perpendicular bisector, then CD has to be 27. Don't overthink it, okay? Let's do another one. This is not part of the figure. Let me go ahead and move that line. It just divides the two examples. All right, so here's what we've got. PS is going to be 13. SR is 13. And we have PQ is 5. We want to find what PR is equal to. Let me rewrite my 3 there. Oh, goodness. All right. So, looking at this thing, we have these sides, right? We have these angles. Well, remember the perpendicular bisector converse, this line, QS, has to be the perpendicular bisector, right? Because it's created, this point S, that's equidistant from the opposite points P and R, right? Or not opposite points, but points on that line that is perpendicular. So therefore, this is the perpendicular bisector. PR has to be 10. Now be careful, it's not going to be 5. Got to be careful of the details here. Of course, that means that this and this are going to be congruent. QR would be 5, so the sum of 5 and 5 would have to be 10. All right. Moving right along. Let's find some angle measures. go ahead and copy down this figure. Here, this is 56 degrees. This is A, B, oops, I'll write that in black. A, B, C, and D. Moreover, AD is 10 and CD is 10. All right, so what we're looking for here is the measure of angle ABC. Do we know how to solve this problem yet? Well, what we haven't been told is the following concept, which we're going to take a little sidebar here. The following is what's known as the angle bisector theorem, okay? Now, I have to warn you guys, there's this sickness to want to bisect things or assume a bisector, and we can only prove a bisector, right? We don't make any sort of assumption. Now, what we have when we have these angle bisectors is the following. We have this angle bisector theorem, okay? And it works as follows. Let's take this point right here. Okay. It's this. If I have A, B, C, and D, what I can know is the following, is that if this guy and this guy are congruent, in other words, AD is the angle bisector, which means BAD is congruent with DAC. Okay? Moreover, if I know that this angle and this angle, right, are congruent, which means that this point right here is going to be equidistant, correct? What I have then is I can conclude that BD is congruent to DC. The reason I can do that, think about it. Again, angle, angle, and then the reflexive side is going to be congruent. Angle, angle, side makes these two triangles congruent, therefore BD and DC are going to be congruent. So let's go back here. Conversely, if BD and DC are congruent, then this is the angle bisector, okay? So let's apply that to the previous problem. It's one of those things that this is easier done than said, okay? So looking again at this, man, that's like a really terribly drawn B, a mutant B. There we go. Let's figure out what ABC is. Now, think about what we just said. We have these two right angles. We have this side and this side congruent, which means that those angles opposite have to be congruent. So this angle right here, ABD, has to be 56. So ABC altogether is equal to 112, right? It's going to be 56 plus 56. All right? Similar figure. Let's do another one of these. All right, got my right angle, I got my right angle. I do need to, oh, this is congruent, This is congruent. So we can make some conclusions about those sides opposite the congruent angles, not the right angles, but the congruent ones. I mean, the right angles are congruent, but the ones that are marked, the non-right congruent angles. In other words, L, M. Okay. And it's this. We know that 4x is Jm, and Lm is 2x plus 12. Okay? And we're going to solve for x. Or, I'm sorry, we're not going to solve for x. We're going to solve for it's Jm equal to. Well, in this instance, because of the angle bisector, we know that 4x is equal to 2x plus 12. Okay? And the reason we can set that up, and we've done this previously, right? When we set something up, we need to give a reason why. We usually do it in parentheses next to it. That's the angle bisector. And now we're going to solve, right? So let's go ahead and get to it. We're going to solve for x, so subtract 2x from both sides. Now we're doing a little bit of algebra. So we have 2x is equal to 12, x is equal to 6. However, we want Jm. Well, we know that Jm is equal to 4x. So we know what x is. We can substitute in 6 for x, and we know that Jm is going to be equal to 24. Okay. In terms of our problem solving today, last thing. Ready? Here's where we're going to start to get a little bit abstract, and we're not working with a coordinate plane. You do not need to graph a single thing, even though we are going to work with a coordinate plane, because this is all going to be done deductively. We're going to write an equation of perpendicular bisector, and this is today's most challenging problem. And I think it's because of the, it's so abstract. With endpoints, we have the point D, which is 5, negative 1, and the point E, which is negative 11, 3. And there it is. That's the whole problem. This problem is going to be more work than you think, okay? Because we have to do the following. If we have DE, and we could graph this on the coordinate plane. I just want to give you guys some semblance of, some sense about what you're doing. But if we graph this on the coordinate plane, and you don't have to write this down because I'm going to erase it in just a moment. 1, 2, 3, 4, 5, right? This is Y, and this is X. Negative 1, so this is D, and then we have E, which is negative 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 3, okay? You guys see here, we're going to connect this, and we want the perpendicular bisector that's going to be somewhere in here. So we need two things. One, we need to know what that point is. Moreover, we need to know what the slope is for this line, okay? Now, you heard me use two magic words, point and slope. If we have a point and we have a slope, we can develop an equation through, of course, the point-slope method. We also could use the slope-intercept form, okay? So either thing is going to work, but we need to extract from DE a point, that midpoint, as well as we're going to need to, create a slope from DE as well, okay? So we don't really need to graph anything because it's going to be inconclusive if we do so unless we do the deductive work. Step 1. We need to find the midpoint of DE. Okay, remember how we find the midpoint. The midpoint of DE is going to be the sum of the x's, 5 and negative 11 over 2, and the sum of the y's, negative 1 and 3 over 2, okay? And we're going to call that midpoint M. 5 plus negative 11 is negative 6 over 2. Negative 1 plus 3 is 2 over 2. Gentlemen, this is negative 3 over 1. This is our midpoint. Now we need the slope of DE. Excuse me. Slope of DE is as follows. Remember the slope formula. The difference of the y's over the difference of the x's let's go ahead and label x sub 1, y sub 1, x sub 2, y sub 2. Okay, so now let's substitute. We have 3 minus 1. I hope everybody's okay with that, right? Negative is a positive. X sub 2 is negative 11 minus x sub 1, which is 5, right? X sub 1, which is back up here, 5. So let's now do the arithmetic. We have 4 over negative 11 and negative 5 is negative 16. So this is negative 1/4. However, what we really need is the perpendicular slope to DE, right? If you remember, it's the negative reciprocal of negative 1/4. So the slope that we really want is positive 4. Remember how we do that? Negative reciprocal, right? We're going to flip over negative 1/4, which is going to be 4 over 1, or just 4, and then we switch the sign from negative to positive. All right, so now we have what we need. Now to get the perpendicular bisector, we're going to do, it's actually up to you guys. I like point slope here, right? Let's review what that actually is. It's going to be y minus y sub 1 is equal to m times the quantity x minus x sub 1, right? And this is point slope. For review. I'll show you right after this how we could do this using slope-intercept. Both things are permissible here, okay? So what we have here, we have y minus, okay, 1. It's equal to 4, substituting in our new slope, times the quantity x minus 3, right? Or positive 3. Now we distribute. We have y minus 1 is equal to 4x plus 12 plus 1 plus 1. And we're going to have y is equal to 4x plus 13. Gentlemen, that is our answer. This is the equation that is the perpendicular bisector to those initial 2 points. Now, real quick, sidebar, could I do this using slope-intercept? And the answer is yes. I think it's maybe a little bit more arduous process, who knows? But it works like this. Remember, slope-intercept is y is equal to mx plus b. The one thing that we don't have here, because remember, this is an x, and this is a y. The one thing we don't have is the y-intercept b, right? So we could actually substitute in here. We could have 1 being equal to 4. And I'm just doing this additionally, right? You actually don't need to do both of these. I'm just showing you guys that these both work. This is negative 3 plus b. So 1 is equal to negative 12 plus b. So 13 is b, okay? And of course, for y equals mx plus b, we're going to plug this guy back in for our b. We already have 4 as our m. So y is equal to 4x plus 13. So it's up to you, whichever one you'd prefer. I really don't care. It gets the same exact answer, but this is our process. Again, find the midpoint, right? The place where we bisect. And then we're going to find the perpendicular, right, slope. And then once we do that, we're going to mash those two together to create an equation using either point slope or slope-intercept. So that's today's big challenge. I'm going to post the assignment on Canvas. If you have any questions, feel free to reach out to me. Good luck.